All right, here's some little work that we're going to do talking about representing the relationship between independent and dependent variables. So this is a continuation of what we did yesterday with independent and dependent variables. So we've got the county fair charges $1 per ride and an additional $3 to get into the fair. Write an equation to represent the total cost for attending the fair. Right now we're at stock show season, correct?
Yes.
Some of y'all might want to go down to the rodeo.
Yeah.
This is a great real life scenario of independent and dependent. So when you get down to the fair, how much is it going to cost just to get in?
$3.
It's going to cost me $3 to get into the fair. No matter what, no matter if I ride 30 rides or if I don't ride any rides, I have to pay $3 to get into that fair, correct?
Yes.
All right. Then, once I'm into the fair, then I get charged how much?
$1 per ride.
For each ride, yes?
Yes.
So we've got ride and we've got our total cost. Which one depends on the other? Think about it. Before you say it, you're going to say, does this depend on that? All right, Sadie?
The total cost depends on how many rides.
Very good. My total cost depends on how many rides that I ride, correct? Would you agree?
Yes.
My total cost, if I rode one ride, would be different than if I rode 3 rides, yes?
Yes.
Okay. So we've got our independent and we've got our dependent variable. Remember when we talked about yesterday, independent is always which axis? Remember, dry mix is X and my dependent is always?
Y.
Okay, so I'm going to write that up there just so that I remember that. All right. Yes.
So like how the independent has to be X and the dependent has to be Y because X always goes before Y.
You can think of that way if you want to.
Independent always goes before dependent because it has to depend on it, so it can't go first.
Okay, that's great. Think of it that way. All right, B, it says write an equation to show the relationship between the independent and dependent variables. I'm going to go ahead again and put my X and my Y. So I'm finding the relationship between X and Y. What was Y again?
Independent.
What was it though?
Total cost.
Total cost. So let's think about X as our number of rides, yes?
Yeah.
Okay, so I'm going to actually put that up here just so we know. All right, so if I want to ride, if I go into it, I know that it's going to be 1X, right? Because $1 for every ride, X being my number of rides, yes?
Yes.
Plus $3, right? Because that's that $3 is getting into that no matter what. Even if I put a 0 in here, right? I still have to pay to get in. All of that gives me my total cost. Would you agree?
Yes.
Does everybody know where I got this 1 at?
Yes. The $1 per ride.
Because it's $1. Why did I multiply it by X? Because it's $1 per ride. Correct?
Yes.
And then where did I get this $3? That $3 is my constant. It's not changing.
Yeah. 10.
All right. So now finding out C. It says use the rule from your equation to create a table of values. Well, let's say that X is going to equal 1. My rule is 1X plus $3. So let me plug that 1 in there. 1 times 1 plus $3 will give me how much? 1 times 1. Okay, good. $4. So if I rode 1 ride, my total cost would be $4. If I rode, I'm going to go with 5 rides. 1 times 5, because now X is 5, plus 3. It's going to give me how much? So my total cost, if I wanted to ride 5 rides, would be how much? $8. Now the ordered pair. Remember, this is my X and my Y. My ordered pair is X, comma, Y. X was 1. Y was, what was Y? 4. So my ordered pair would be 1, comma, 4. What about if I did 5 rides? What would my ordered pair be? 5, comma, 8. Do 10 and do 15. Now that I have my ordered pairs, will I be able to graph it?
Yes.
Absolutely. So I want you to go ahead and finish this, and then we'll look back at it in B class.